Okay, so the next transformation we're going to cover is called dilations. So you guys should have this note sheet in front of you. We're just going to follow these instructions down here, and we're going to learn about dilations as we go down. Okay, so number 1 says plot the points A, B, and C on the coordinate grid and connect the points. So we're going to be making a triangle. So A is at 4, 1. We're going to go over 1, 2, 3, 4, up 1. There's A. B is at 1, 5. Over 1, 1, 2, 3, 4, 5. That's B. And then C is at 1, 1. Right there. C. I'm going to connect these points. And there's my triangle. Okay. So this chart that we see to the left lists the points for A, B, and C, and now it wants us to find the lengths of the segments. That's the lengths of the sides of the triangle. So for this horizontal and this vertical side, that's going to be easy. All we have to do is count along that line. So for AC, I'm going to count 1, 2, 3. Find AC here, and that's 3. All right, BC, that is 1, 2, 3, 4. 4. This diagonal is going to be a little bit more difficult to count, but if you guys can remember, we have a special theorem for determining missing sides of a right triangle. If you guys remember what that is, it's called the Pythagorean theorem. Okay? And all that says is for a right triangle with sides A, B, and C, it says that A squared plus B squared equals C squared. Okay? Alright, but before you go ahead and put those numbers in and calculate what C is going to be, I'm going to tell you a hint. Okay? We're going to cover this later in the semester, so you're going to learn about it then, but they're called special triangles. And this special triangle is called a 3, 4, 5 triangle. So if this side is 3 and this side is 4, you guys can guess what that last side is going to be. Okay, 3, 4, 5 triangle, that last side is going to be 5. So our missing piece here is 5. Okay, so now we're going to go down to number 3. We're going to transform points A, B, and C under the mapping. You guys should remember the word mapping to create A prime, B prime, C prime. Okay? The mapping says that xy becomes 2x, 2y. So, if our first point was 4, 1, we need to multiply x by 2 and y by 2. So it's going to become 8, 2. B prime is going to be 2, 10. And then C prime will be 2, 2. Alright, so now we're just going to graph our new triangle. So I'm going to do A is 8, 2, well A prime. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. Okay, here's A prime. B prime is 2, 10, so that's 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is our B prime. And then C prime is 2, 2. 1, 2, 1, 2. That point there, C prime. Okay? We're going to connect all of these dots there. Okay? And then B to A. Alright, so there's our triangle. Now we're going to find the length of this triangle. So we look for A prime, C prime, count 1, 2, 3, 4, 5, 6. That's A prime, C prime. B prime, C prime, we're going to do the same thing, we're going to count. So that is 1, 2, 3, 4, 5, 6, 7, 8. Alright. So you guys can see, this one's 6, this one's 8. You could plug these into the Pythagorean theorem to figure it out, or you could kind of see the pattern is going so that this is 10. Alright. So now you guys have to look at the numbers, look at where we started, look at where we ended up, and you can kind of see a pattern of what happens to each number. Okay? How 5 gets to 10, how 3 turns into 6, and how 4 turns into 8. Okay? Each of these is multiplied by 2. So, what the dilation happened was that it got bigger, and each of them was multiplied by 2. That 2 is called the scale factor. Okay? So when we go down here, we're talking about scale factor. Scale factor is how we can determine a change in size from one shape as we get to the other shape. That's why it has to and from. So if we go to the big triangle from the small triangle, that's going to be our scale factor. The important thing for scale factors is that you use corresponding sides. What I mean by that is you want to use sides that are in like the same place, the same position on that shape. So a good idea is to look at the letters and then their corresponding prime. So if we use AB as one of our sides, as it says in number 7 to do, then we're going to use A prime, B prime as our other side. So let's go ahead and calculate the scale factor for our triangle using AB and A prime, B prime. So we are going to the big triangle from the small triangle. So our ratio, it's always going to be a ratio. Our ratio is going to be the big triangle is 10, small triangle is 5, and what's 10 divided by 5? 2, just like we said earlier, how everything was just multiplied by 2. Our scale factor is 2. Your scale factor is always going to start out as a ratio. It's always going to be positive because we're never going to have negative lengths of sides to use. Okay? And then you guys see here it's a positive 2. This positive 2 is greater than 1, and our shape got bigger. If our scale factor is less than 1, that means our shape is going to get smaller, because if you have a scale factor of 1/2, it's going to make everything half as big. So it's going to get smaller. Okay. We're going to talk more about scale factor in a minute to find missing sides. First, I want to talk to you guys about angles really quick. If we look at the angles of our small triangle, and then we look at the angles of our big triangle, what is the relationship between those? So if we look at this angle here, angle C, and then angle C prime here, they're both right angles, right? And if we look at B and B, these angles are the same as well. And then A and A prime, those are the same as each other. So the angles didn't change when we dilated our shape. All that changed was the length of the sides. So we want to make sure to remember that the angles do not change. So that means that the corresponding angles are congruent. Okay, so the corresponding angles are congruent. And you guys know what I mean by corresponding. It means C corresponds to C prime, A corresponds to A prime, and B corresponds to B prime. That's all that means. Alright, so now we're going to flip over papers. We're going to be talking about this word that's right here in number 9, center of dilation, for just a second, and then we're going to jump back into scale factors. So everybody flip over your papers, flip over your notes,